Hi, good luck with this practice test. This is the first one in Quadratics up to about the end of Factorization and just some basic ideas about the graph. So are you ready? Now we'll do the usual. That is, I'll take you through question by question. I want you to pause the presentation and do the problems either on screen or on a piece of paper or something, and then move on. And at the end, pause it, finish, and then watch me go back to the beginning and do all the problems and mark your work. Let's have a look now. Here's question 1. See how you go with that. Pause it and have a go. I'm going to go on now. Let's go to question 2. Here's question 2, factorizing. Okay, and pause it. Let's go to question 3. Part A and B there. Have a go at those. Let's go on to C and question 4. Solving quadratic functions there, so quadratic equations. Let's go to 5. Okay, and 5b, have to maybe scroll back and look at the graph again. Question 6, using technology here then. Question 7, part A, and then I'll give you another set of axes for part B. Here we are. Few parts in question 8. Okay, A and B. 2 marks each. Let's go on. C and D. E and F. And question 9 now. Got a bit of work there, X and Y intercepts, and draw the graph. You might have to come down a bit if you're going on screen with the graph here. Eight marks altogether there. And I think our final question is question 10. Alright, let's go to the last parts of it. Part C there. And that's the end of the test. Okay. Are you ready? Let's mark your work, come back and let's see how you went. Let's go right back to the beginning now. Right up here, and here we are. The first question, don't forget to put your name on the paper. You want all the marks you can get here. Okay, total marks 55, really should have taken you about 55 or 60 minutes. Let's have a look now. Place your G, F or N in the box below. The general form is y equals ax squared plus bx plus c. The factored form is when you have this type of form. So let's have a look. The first one is the general form. So this is G and this is F, and the other forms are neither. So this is factored. This is general, except it hasn't got an X term, but that doesn't stop it from being general. This is neither, because it's a vertex or perfect square form. And this is really a factored form. This is a tricky one, because the square there means it's really symbolising this. So it is factored. So mark one right, or give yourself 1 mark rather, for each one you got right there, making a total of 5. Okay, let's go to question 2. Question 2, factorized form, means you're going to try to do the reverse of FOIL. So putting an X in front of each bracket. You need factors of 12, 12 and 1, or 4 and 3, or 6 and 2. Really, when you're writing those down, you should have a system. 12 and 1, 6 and 2, 4 and 3. Okay, you look at the 7. Oh, 4 plus 3 is 7. So let's try plus 4 and plus 3. Okay, let's check it. X by x is x squared. 4 by 3 is 12. And then the middle term here, 4x. And 3x is 7x, which checks. Okay, so you're able to check it with FOIL. The expansion rule, firsts, outers, inners and last. Let's do it again for this one over here. You've got 3 terms and you know that's what's produced by an expansion using FOIL. So I'll put that much. Factors of 15, 15 and 1, nothing and 2, try 3, 5 and 3. I think that's the one because we have neg 2 in there. So one has to be positive and one has to be negative. So you've got a negative there. And the larger one wins here, the larger in size. So we'll make it neg 5 and positive 3. Neg 5 by positive 3 is neg 15, which checks. X by x, x squared checks. And what's these here now? Neg 5x plus 3x comes to neg 2x, so it checks. That one checks as well. Okay, let's mark it now. There are 4 marks. Basically, there's a mark for each bracket there and a mark for each bracket there. Okay, how are you going? Getting a few marks? Let's go down. Number 3, expand. We're going opposite. This is doing some foiling now. Let's do it. 2 by 3 is 6. 2 by neg 3x is neg 6x. Neg x by 3 is neg 3x. Neg x by neg 3x. Negative times a negative is a positive. X by x is 3x squared. Okay. And then we should collect up the terms. Let's put the conventional term to be first as the highest power, and that's its sign, so it's 3x squared. Then we've got neg 6x, take 3x. Let's just check that on a number line. Neg 6x down there. And then we go another 3x. So we're down at neg 9x. Okay, neg 9x. And then we put the 6 on. The sign for the 6 is always to its left. Any term sign is to its left. So we've got that. So we've got 1 mark here and 1 mark here out of 2. Okay, just put a 0 there. All right, how are we going? Let's go down. And this one we're expanding, so let's look now. Let's do the bracket first. It means p take 3 by p take 3. But at this level, you're supposed to know the perfect square expansion. First one squared plus twice the product, 6p, plus second one squared. You can do FOIL if you must. Okay, and then multiplying this out, 2p squared, take 12p, and plus 18. Alright, so what have you got here? We've got 1 mark for this expansion in here, and 1 mark for multiplying it all by 2. Okay, a score out of 2 there. Okay, let's go down to part C, slightly different. Let's do the bracket first. So neg 3 by x squared is neg 3x squared. Neg 3 by 1 is neg 3. Let's then put it in the usual order. Highest powered term first, neg 3x squared. X term is plus 2x, and then take 3. Okay, there's 1 mark for that multiplication of the bracket, 1 mark for collecting the terms up. Getting a few? I hope so. Let's go down to question 4. Use the null factor law to solve the following quadratics. The null factor law says if there are two terms multiplied to give naught, one of them must be null. Either that is naught or that is naught. So that implies that x equals, add 3 to both sides, that implies x equals 3, or here take 1 from both sides, x is equal to neg 1. And I think we've got to change the mark scheme here, and there should be 4 marks, I think, because we'll have 1 for each of these answers. And then in the second part here, 2 terms times to give naught. It means one of those factors must be 0, either that one or this one. Dividing both sides by 2, x would be naught, or adding 4 to both sides, x would be 4. So 1 mark for each of those. Give me a total of 4, not 2 for that question. So I think we've just gone up to 57 marks for our total now. Okay, let's look at question 5. I skipped a bit there, let's just go back. So question 5, consider the graph. This is the general graph. Values of A, B and C have deliberately been left out. State with reason whether the value of A is positive. So A is the number in front here. And this is called convex shape or concave up. The cave is on the top. Okay. Now we know that that sort of function always has A greater than naught, that is, it's positive. And we put our reason because the graph is convex or concave up. So you must have the reason. It says with a reason. So 1 mark and 1 mark for the reason. Okay, let's go down to part B. State with reason, here it is again, whether the value of C is positive, 0 or negative. Now the value of C, this value, is when you put x is naught, those disappear and you get C. So along the y-axis, x is naught, so the C value is the y value where it cuts the y-axis. So C is down here in negative land. So the answer to this question is C is negative because it is the y-intercept, or some such statement like that. So 1 for saying it's negative and 1 for saying why it is. Okay, let's go down then. Question 6, using technology, solve that equation. There's a couple of ways of doing it. You could draw the graph. Let's put this down now. You could go to graph mode, put the function in, y1 equals 2x squared, take 5x, take 11, then go shift F5, or draw it, check the view window, the initial would probably do it, shift F5 and choose root for the solution or root of an equation. Technically that should be in GSolve. GSolve means graph, solving a graph. It should be the zeros or the x-intercept, but your calculator uses root. And then you can cursor across between the two roots. Probably better though on a calculator is to use equimode. If you do that, you then choose F2, which is polynomial, and then degree 2, because the degree is the highest power of the variable there, and the highest power here is x squared. And then enter the values. That's 2, neg 5, neg 11. Hit execute and you'll get the answer that way. So what are the answers? Watch it. 2 decimal places. So it's x equals 3.907, I think, which to 2 decimal places 3.91. Got to round it up. And the other x value is, I think, neg 1.40 something, but it rounds up to 1.41. Okay, so there's 1 mark for each of those. Remembering to round 2 decimal places. If you didn't round 2 decimal places, got the right numbers, but more of them, just take off 1 mark. Okay. How are you going? Getting some, I hope. Let's have a look at question 7. Again, it's about these A, B and C values. Now, A has got to be negative. So that's concave, or concave down. And C is greater than 0. So this is the y-intercept. So it's going to cut the y-axis in the positive region, but it's got to be downwards. That's something like that. Remember the cave? Here you are, you're sitting in a cave, got you in a little cave there. Okay, so this is concave, and that means A, that's because A is less than 0 rather, it's a negative. And the C value is greater than 0, that's the y-intercept. Okay, get the hang of that. So it's 1 mark each for concave there and for the y-intercept there. One of each of those. All right, let's have a look at the next one. A is less than 0, so that's concave again, but C equals 0. So it's got to look like this. Cuts the y-axis at y is equal to 0. Okay, so that's that value there. So there's 1 mark for the concave down and 1 mark for that point there. All right, let's go on. Doing some fundamentals about this graph, basically. Let's look at question 8. Solve the following quadratics using the method of factorizing. Okay, is there a common factor in these 2 terms? Yes, there's a 2 and an x. Then we put a bracket. What do you multiply 2 by? Get 2x squared, you need another x. Then we have this take, so take. What do you multiply 2 by to get 4x? It's another 2. And you can check it by your expansion. 2x by x is 2x squared. 2x by neg 2 is neg 4x. Then by the null factor law, these 2 multiply together to give 0. So either the first one must be 0 or the second one. 2x equals 0, divide both sides by 2. X must be equal to 0, or add 2 to both sides here to solve for x. X is equal to 2. Okay, only 1 mark for each of those answers. Or just 1 mark up here if you factorise it but didn't know what else to do with it. Let's look at the next one. Factorising, we recognise this one. This comes, it's a 3 term, and you can recognise this as a result of FOIL. X by x is x squared. Now we need numbers together, multiply together to give 16. 16 and 1, 8 and 2, 4 and 4. We'll pick these 2 so that we come up with 8x. Or if you're really being smart here, you might recognise this as a perfect square form. A squared plus 2ab plus b squared. Let's put the 4's in. 4 in there and 4 in there. Positive and positive, check it. 4 by 4 is 16. Then 4x, and that other 4x is 8x, which checks. So we've got our factors. Therefore x plus 4 is 0, twice if you like. It's a repeated factor. So take 4 from both sides. X is equal to neg 4. And that's a repeated root of that equation. So repeated root or solution to that equation. Okay, so we've got 3 marks for that one. So what we would do is have 1 for the factorisation and 1 for putting the factor equal to 0 and 1 for stating the answer. Okay, so mark it out of 3. Let's have a look. We just flick that again. So back up here. Again, it looks like a FOIL expansion. Okay, so let's do it. X in the front of the 2 brackets. We give x squared. Numbers multiply to give 2 for FOIL, of course. 2 and 1. So that's just going to be 2 and 1. And if we put a plus, we get 2, which checks. We also have 2x and 1x, which adds to 3x. So we've got our factored form. Now we want to solve the equation. The two factors multiply together to give 0, so either one or the other must be 0. Therefore x is neg 2, or x is neg 1. Same again, so 1 for the factorisation, and then 1 each for the two answers there. Okay, how are you doing? Let's go on, nearly there. So you've got D and E here of the factorisations. Okay, this is a two-term factorisation, and you might remember that if you FOIL this special product, A plus B by A take B, the middle terms cancel out, you get A squared take B squared. Can you do that in reverse? This implies x squared take 5 squared. So yes, we have got the difference of two squares. That's x plus 5, working backwards from FOIL, by x take 5. Okay, so that's a special form. You've got a product equal to naught. So one of those two factors under the null factor law must be naught, or 0, or null. So this means subtracting 5 from both sides, isolating x is neg 5, or adding 5 to both sides, x is equal to 5. Again, this is pretty hard work for only 2 marks. It's 1 for the factorising and 1 for the two answers there. Okay, let's look at part E and F. We've got a couple of parts here, and I think that ends our factorising. Let's have a look at this equation here. X squared take 3x plus 2x. Well, let's join them together for a start. That's x squared. Neg 3x plus 2x is neg x equals 2. Now, we can only solve this using the null factor law if we subtract 2 from both sides and make it equal to naught. So we can use the null factor law then. Then we recognise there's a FOIL type expansion, so we try to factorise it. I want numbers multiplied together to give neg 2, so it's 2 and 1, so it could be neg 2 and positive 1, negative times a negative is positive, negative times a positive is a negative, that's what we want a negative product here. So, and the bigger one must end up negative, so it'll be x take 2 and x plus 1. Neg 2 by positive 1 is negative 2, and neg 2x plus 1x is neg x. The bigger one wins there. Now we're saying product is 0, either that factor is 0 or this factor must be 0. So x is equal to 2 or x equals neg 1. Our solution then. 3 marks. Okay, what are they? Well, it's a bit skinny here. I would say there's 1 mark for that. And then 1 mark for that. And 1 mark for 2 answers. I want to give that 4. So can we increase that to 4? So we're up to about 61 now, I think. No, we've added, what have we added? Just 1 mark there. How many additions have we made? Yeah, we're 55, so we added 2 marks, 57, up to 58 marks, I think, now, for our total. We'll check it in a minute. All right, so let's look at this one. You know the basic structure for solving an equation is have all terms across on one side, so let's just see if we can make this equal to naught by subtracting 5x from both sides. We subtract it from there, subtract from the other side. We're going to end up with 25 take x squared equals naught. That looks very similar to the one we already did, because this is 5 squared take x squared. So that's a perfect square form. So it's 5 plus x, first plus the second, first minus the second. So we can then say either 5 plus x is naught or 5 take x is naught. So x is neg 5 or x is 5. Okay, fair bit of work for 3 marks. Let's make it 1 mark there for rearranging, and then 1 mark for factorising, and 1 mark for the 2 solutions. I'll leave that one at 3. Okay, let's look at question 9. Got a graph to draw here. Find the x and the y-intercepts. Let's do the x-intercepts. X-intercepts occur when y is 0. So we would have this function, 2x take 48 plus x squared equals 0. Looks a bit strange, so let's put the x squared first. That one, and 2x, its sign is in front, plus 2x, take 48 equals 0. Now, what do we want? We want to try to reverse FOIL. Factors of 48. Let's do it over here. 48 and 1. 24 and 2. See the system? Going up by 1, 8 and 3, 6 and 4. Leave it at that. Now, which 2 are you going to choose? I think these, because of the plus 2x there. So let's try and put it in. The winning term is positive, so the bigger one must have been positive. Plus 6, bigger size number. And take, hang on, what have we got here? 48. Oh, 6 and 4 is not right. 6 and 4 should be, what have we got here? Should be 6 and 8. I've gone backwards here. So when we put in 3, should be 16 and 3, and then 12 and 4. 12 and 4, and 16 and 3, and I don't think we can do it, can we? What else have we got? We got 6 and 8. Yeah, so there it is. Yep. Went haywire there with my factors. So we want 8 and 6, and we want the bigger one to be positive. So that's going to be plus 8 and take 6. So positive 8 by negative 6 is negative 48. And then plus 8x take 6x. The bigger one is positive, so the winning number is plus 2x. All right, can we now put those factors equal to 0? This one equals 0, or this one equals 0. So x equals neg 8, or x equals positive 6. Let's mark those now. Here's positive 6, and negative 8 down there. We'll use the scale of just 1, 2, 3 along there. Let's go up here and do the y-intercept. Well, we should write these as correct points, couldn't we? Shouldn't we? The points are neg 8 0 and 6 0. Right? Intercepts or any points have 2 coordinates. Y-intercept is when x is 0, so let's look at the function. 2x take 48 plus x squared, so this is the usual c value, been written in a different order here. But those 2, when you substitute in 0, will give 0, so the point will be 0, neg 48. Come back and do some marks in a minute. Let's go down here. Well, that's why all this is so big. So 10, let's call this neg 10, neg 20, neg 30, neg 40, 2, 4, 6, 8. So there it is. Let's mark them in now. 0, neg 48. This one was 6, 0. This one was neg 8, 0. Now in drawing this, we don't have a vertex or a turning point, but we do know the turning point is a point of symmetry, so it's halfway between these 2 values. So let's have halfway between neg 8 and 6 is the mean of the 2 numbers. Halfway between 2 numbers is their mean. This is neg 2 on 2, which is neg 1. So the axis of symmetry is actually halfway between these two, going down like this. So although we haven't found the actual point in this first part, we will say it's somewhere down here. Don't know. Let's try and draw our graph now. So this is going to come down, 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 and then up through there. Okay. Okay, so the vertex will be a bit lower than that neg 48 because we know the axis of symmetry here is x equals neg 1. Now we've got to look at some marks for this. So let's just scroll back a bit. What are we going to give for this? I think 1 mark for this line, okay, and 1 mark for each of these, 3. 4 over there, and let's go down and mark our graph. 4 and then 5, 6, 7, and somewhere for the symmetry line to get that on the correct side over there on the left of the axis, 8. Okay, so a lot of work. It's a big question, and that's of course where the quadratics work is heading, to fully understand the quadratic function and its graph. Let's go to question 10. Graph on the axes below, sketch the graph of any quadratic that has 2 x-intercepts. Well, I'm just going to draw that one. Okay, so that's worth 1 mark. 1 mark for that. Write down a quadratic function that has 2 x-intercepts. Y equals, I know what have I got there? X take 2, yx take 3. If that's 2 and 3, then that's what the factors would be. That would do. Or I could expand it. X squared take 5x plus 6. So what I've got to do for the 2 marks here, we've got to show that this was going to be able to produce two answers. So 2 factors or some function here that would give that graph. We have 2 intercepts here. Okay, part C. Let's have a look, and this is our last part. If we use the calculator to find the solution of that equation, we find there's only one solution. What is the graphical interpretation of this? Well, how can a quadratic, so let's look at it, a quadratic like that or like this only have, what's this? Putting it equal to 0. These are the x-intercepts where the function equals 0. So how can it only be one of them? Well, let's see, draw the 2 scenarios. It could be convex and just come down and touch. So there's just one x-intercept there. Any of these. Or it could be concave and come up and just touch at one point. Okay, so there's 1 mark for that. Anything that looks like that. Okay, I wonder how many marks you got. Let's just scroll back and total our marks. So we did change them a bit to give better rewards there. So we've got 1, 3, 4, 12 there, 15. Change that to 4, so it's 19, 21. Okay, 21 to there, 24, 27, 29, 31, getting a few together here, 31, 33, and coming up here, 35, 37, 39, 39, we added some there, that's 43, 43, 45, 47, 49, 53, it came to 58. Okay, so how did you go? That should have taken you almost an hour to do that. If you did it in under that, that's good. That's 58 marks. You might change that to a percentage and see what you think. All right, so I hope you enjoyed that. It gives you a bit of practice, and you know what areas you have to concentrate on before the actual test. So I want you to go away and work hard on those. But for now, it's cheers from me. Catch you later on.